factor a trinomial with a leading coefficient of 1. Now we're going to take a look at factoring trinomials that also have a GCF. So looking at our first example, looking at all three terms, I notice they have a common factor of 2. So the first thing that I'm going to do is divide 2 out of each term. So that leaves me with x squared minus 6x minus 16. So now we set up our chart. Sorry, not an XY chart. We're setting up our t-table chart. So we think about what multiplies to negative 16, that's our constant, the number at the end without a variable, and what adds to a negative 6, and that's the term in the middle that's being multiplied just by an x. The first numbers that come to mind for me that multiply to 16 are 4 times 4. In order to multiply to a negative 16, one of those would need to be negative. But negative plus 4 does not equal negative 6, it equals 0. So another set of numbers that comes to mind is 8 times 2. To multiply to a negative, we need one of those numbers to be negative. And since we're also adding to a negative, I want the greater of the two numbers to be negative. And negative 8 plus 2 does equal negative 6. So this is where we split up our middle term to be rewritten as negative 8x plus 2x. And then we factor by grouping. So for my first two terms, I can factor out an x. So x squared, when you factor out 1x, you're left with 1x. And negative 8x, when you factor out the x, you're left with negative 8. My second two terms have a common factor of positive 2. When I divide that out of each term, I'm left with x minus 8. And I'm keeping my GCF out front, the 2 that I factored out in the first place. And then looking inside the brackets, I notice I have a common factor of x minus 8. So I keep my GCF, I factor out my x minus 8. From the first term, I'm left with an x. And from my second term, I'm left with a plus 2. So that's our final factored form. We'll just see a few more for some extra practice. My next set, I notice that I have a negative in front of my y squared, and I really want that to be positive, otherwise it makes it very challenging to factor. So the first thing I'm going to do is factor out that negative 3, leaving me with a y squared. Dividing positive 24 by negative 3 gives me a negative 8y, and negative 21 divided by negative 3 gives me a positive 7. So when you're factoring out a negative, make sure you keep track of your signs. Setting up my chart, this time I'm multiplying to a 7 and adding to a negative 8. Well, the only numbers that multiply to 7 are 1 and 7, but 1 plus 7 is positive 8. So what that means is that both of my numbers must be negative. Negative times a negative gives us a positive 7 and adds to negative 8. So I'm going to rewrite my negative 8y as negative 1y, or negative y, plus negative 7y. And then factoring out the common factor for the first two terms, it's a y, leaving me with y minus 1. Make sure you remember that you're dividing, so the y divided by y leaves you with a 1. And out of my second two terms, I see a 7, but I want to think about if it's a positive or a negative 7 that I should factor out. And noticing that the signs are opposite on my second two terms, I want to factor out a negative 7. So that leaves me with a positive y, and positive 7 divided by negative 7 is negative 1. So now I have my two binomials that match. So factoring out my y minus 1, that leaves me with a y for my first term and a negative 7 for my second term. So if you're feeling comfortable with this, you can go ahead and stop. If you want to see one more example, we've got one more that we're going to walk through. So my last set, what I'm noticing is that they all have a common factor of 5, but also all of my terms have an n. So I'm going to factor out 5n, leaving me with n squared plus 6n plus 9. So now I set up my chart, I think about what multiplies to a 9 and adds to a 6. And the first numbers that come to me for 9 are 3 times 3. And sure enough, 3 plus 3 equals 6. So I'm going to rewrite my 6n as 3n plus 3n. So the common factor for my first two terms is n, leaving me with n plus 3. For my second two terms, it's 3, leaving me with n plus 3. So factoring my n plus 3 out of each term, I'm left with n plus 3. Another way to express this, since those are the same, is you could say n plus 3 squared. Because remember, to square something means you multiply it by itself.